Welcome back to Math Success Seminar Online. I'm your host, Kevin. Today I'm going to talk about one-step algebra problems, but now with fractions. So here we have this pretty simple looking problem. X minus 3/4 equals 2/3. So when you're dealing with algebra problems, what is the goal? The goal is always to isolate X or isolate your variable. So I'm just going to say isolate variable. So how do we do that? Well, in this particular problem, you want to think of this equal sign as separating two different sides. So you got left-hand side, right-hand side. So this left-hand side is the one that has the variable in it right here. And we want to get this alone. But we have this 3/4 hanging out with it. And we don't want that 3/4 hanging out with it. So we have to undo whatever operation this is here. And this also goes back to order of operations. Just listen them out. Those go together, those go together. So since we're subtracting 3/4, the way that we can get it away from X is by undoing subtraction. How do you undo subtraction? With addition. And writing this vertically looks a little confusing, so all you have to know is that this and this are going to cancel out. Negative 3/4 plus 3/4 goes away. So now on the right-hand side, we have 2/3 plus 3/4. And now we can just add them and be done. But whenever you're adding fractions, you want to be careful because there's a compatibility issue. In order to accurately add these together, they have to have the same denominator, which is called the least common denominator, the lowest common denominator. So what is the lowest common denominator between these two? Well, 3 is prime and 4 is a collection of 2 primes, so really it's just multiplying the two together. I have a separate video on how to find least common multiple and lowest common denominator, which I'll probably try to figure out how to link below or make an annotation there. So since I know that my LCD is going to be 12, but before going straight to 12, I'm going to rewrite the fractions but leave a little bit of room. How do we make this 3 into a 12? Well, we have to multiply it by 4. If we multiply the bottom by 4, we have to multiply the top by 4. How do we make this 4 into a 12? We have to multiply by 3. Multiply by 3 here, multiply by 3 there. So now this, we're going to have 8 over 12 plus 9 over 12. And now that these two have the same denominator, you can add the numerators together. 8 plus 9. So that'll be 17 over 12. This is a possible answer. This is written in improper fraction form. Another way we could write this is with a mixed fraction. So how many times can 12 go into 17? How many times can 12 go into 17? Just making sure I'm saying that right. It can go into it once. So if we take 12 away from this, we'll have 5 left over. So I think either one of these, depending on the homework you're doing or the type of quiz you're doing, usually if they give you a mixed number to start with, they want the answer as a mixed number. But if they don't really specify, sometimes it's okay to leave it like this. Now the other type of problem . So here we don't have an x, we have a j. which, is that okay? Is that a good looking J? It's the letter, which is the variable, which is the thing that you're trying to solve for. So we have 3/25 is equal to -1/5 J. So there exists a number that we can multiply by -1/5 to make this number. And this goes back, I accidentally erased it, but PEMDAS. Those go together, those go together. So what's the goal? The goal is always to isolate the variable. What does that mean? It means you can think of it like a left room and a right room. We want to get the variable in a room by itself. So whenever you have a number, even a fraction, and a letter right next to it, it's implied that this is supposed to be multiplication. How do we undo multiplication? How do we get it away from the variable? We undo multiplication with division. So I kind of ran out of a little bit of room here. That means we want to divide both sides by this fraction. Notice I'm using brackets. Brackets you can think of as a special type of parentheses. Basically this P parentheses is for like grouping symbols, but I'm going to group this because I want to think of that as a single item, and I want to think of J as a separate item. So we're going to divide both sides by this. I'm just going to write it all out, put it all on the line right now. Try to keep track of all this. The main takeaway here is making sure that you have this left-hand side in the correct order. 3/25 divided by -1/5. Because this -1/5 and this -1/5, if I'm dividing this by that, they're going to cancel each other out and leave 1 behind, the number 1. And 1 times J is just J by itself. And now we have a division of fractions. Division of fractions is a special type of problem that you want to think about. Because whenever you're dividing fractions, or whenever you see the division symbol with fractions, or even if this was a normal number or that was a normal number, you want to keep the first fraction, you want to change the middle to multiplication, and now you want to flip this onto its head, -5/1. Because seeing division of fractions, it's not exactly clear how you're supposed to go about combining the two. So changing this to an intermediate step like that, I think is the most helpful. I'm going to group that just to show that this negative is on this fraction. Because now, how do we deal with this? Well, we just multiply going straight across on the numerator, straight across on the denominator. So it'll be 3 times -5 over 25 times 1. And I'm going to multiply these out and then cancel. It is possible to cross-cancel these first, but I'm not going to show that here. I'm sure we'll have examples in the future where I'll do it. 3 times -5 is -15. 25 times 1 is 25. So now, is there any number that 15 and 25 share? Well, a keen eye would notice these are both multiples of 5. So this is 5 times what? 5 times 3. 25 is 5 times 5. Now that both of them share a common factor together, 5 and 5, those cancel out to become 1. So anything that the numerator and denominator don't share, whatever's left is going to be your solution. So this turns out to be -3/5. So those were just two small examples. Those were just two smaller examples of one-step algebra problems. Hopefully, if you're going through homework or something like that, these can help you along. I'm going to go over two-step pretty soon. But that's all for right now, and I'll catch you next time.